Okay, guys, we are kicking off the second stream of the day because unfortunately I had to give a talk. There was some MIT organized event and we also had Niels Reimers in my Discord. So because of those two, I had to skip the second stream. So sorry for that, a bit slower today. But we're going to compensate for that. Over the next day, 100% focus. I don't have anything else to do other than this. Let's go through Cohere's IA effort. I didn't see it until today, actually. Let me ping Chris as well. Or you can just chat here. Okay. Guys, hope you're doing well. What I want to do now is go through the IA effort. I want to understand a bit more what it is. Let me turn on the live chat. I just found out about this effort. It looks very exciting and looks very similar to what we are doing. Let's first just go through the channel here. I'm curious to understand what it is about. Apparently they're collecting languages for different languages, and they are mentioning even no language left behind somewhere. So that seems there might be a big overlap between what we are doing and what they're doing. Let's check it out. Maybe let me tag people in our server. Let me just say open NLLB. Cohere's IA effort seems very similar to what we're doing right now. Who wants to join? Pop in. Okay. Let's go. Open it up. Let's start at the beginning here. Welcome to IA. We're glad you're here and we look forward to working together to make sure no language is left behind. Come on, it's literally the same. Open Science Initiative. Follow these steps to start contributing your language to our Open Science Initiative. We literally, like, our getting started, our first task in the getting started is literally this. Like, let me show you what we have in getting started right now. If you go to my GitHub here, if we open up OpenNLB, if we go to getting started, data collection. If you wish to help with collection of brand new parallel corpus, we're happy to support you. Please flag them to us, blah, blah, blah. Although we are more talking about parallel data, Cohere is just focused on monolingual data as well. Well, we can later use it to basically mine it, but yeah. Review the project info. Learn all about IA here. And on the site, IA project, I'm gonna open it up in a second. I'm gonna see what it is. And then there is project info. Oh my God, there is just a ton of resources here. Okay, let's see what it is. What are the goals? What is IA? Let's see, IA is an open science project that aims to build a multilingual language model by instruction tuning that harnesses the collective wisdom and contributions of people from all around the world. In the IA multilingual project, we want to improve available multilingual generative models and accelerate progress for languages across the world. The word IA is derived from the Tiwi language and is translated to fern. IA is a symbol of endurance and resourcefulness, which represents our own commitment to lead a long-term multi-institutional effort in advancing multilingual models and making gains in underrepresented languages. Contributing to IA is open to anyone who is passionate about advancing the field of NLP and is committed to promoting open science. You don't have to be an AI expert to be involved. We're looking for everyday citizens, teachers, linguists, and lifelong learners. We will be open sourcing our models, training data, and the data collection tool as part of the project. Nice, 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 nice. Maybe we can have some type of symbiosis relationship with them. Why does it matter? Around 400 languages have more than 1 million speakers, however there is scarce coverage. Okay, we already know all of this. Who is organizing this? London supported with compute and research by Cohere for AI, a research lab that seeks to solve complex machine learning problems. However, it is a truly multi-institutional initiative with the help of a community of researchers, engineers, linguists, social scientists, and lifelong learners from over 100 countries. Let's see the team. Oh, Sarah Hooker is one of the leaders. Nice. She's behind the hardware lottery paper. What are plans to open source? We'll make the license on any research artifacts as permissive as possible. As permissive as possible, huh? We intend to release it with a license similar to Bloom. Rails. This allows for both commercial and non-commercial use cases, making it the most open source license permissible. It's not the most. The most one is MIT. Just go MIT if you want the most open source one. What are your plans to open source? What does that mean? What are the goals for each language? 5,000 contributions to the rate model performance task, aka task 1, and 4,000 contributions to the contributor language task, task 2. Okay, track your language's stats on the analytics page here. Let's see what this is. Unique submissions. Asia has the most, then Africa. Europe has only 5,000. Interesting. Tabular view. Okay. Let's see, where can we break this down onto content or onto countries, not language analytics. Region, blah blah blah. Unique submissions. Let's put Europe. I'm curious to see quickly about Serbian. Only 110 submissions. Okay. Let's see here, task 1, task 2. Aha, so this is unique contributions. Mostly English here. Overall analytics. Top 10 languages. Tamil. Telugu, Wolof, Somali, Portuguese. Interesting. General stats. Total number of users contributing for task 1, 1,000 users. Who audited generated task for 1. Who audited contributed task for 1. For task 2, much less. Okay. I should have asked Niels about this project while he was giving a talk. Man, I didn't know about this. How didn't I know about this, guys? Why didn't anyone tell me about this? Actually, Sarah, my girlfriend, did tell me, but I completely ignored it. She's gonna kill me. She's probably listening to this stream right now. How are contributions recognized? All physical prizes will be mailed out at the end of the year. Okay. Members of top 500 who achieve 500 contribution points on the IL leaderboard are eligible to receive digital certificate and badge, limited edition stickers, notebook. Lol. Just give me the money. This will include. Okay, they're just trying to create some incentives there. Okay. That's what you get for ignoring the girlfriend. Exactly. Guilty as charged. Let me see. Where is the start here? Let me see what they are writing here. Nice. Okay. Let me see. Where was the Yoruba contributors? Telugu, Chinese, Igbo, Polish. They have different events here. Yoruba, Tamil, Telugu, mostly Malay, Aya, Igbo. This is now just in the future. Every day there is something going on. Not that many people though. Where was the... I can't find the original event here. Indicate which languages you speak. Create strong prompts and completions. Learn what makes a good prompt. Join the events. Join the Wednesday session. The video to get started. I think I have this one open. We're gonna watch the video as well. Let's see some announcements. And this one, social posts boosts. This help boost this one specific to Portuguese. Are they helping each other by liking their posts? That's not how it works on LinkedIn. It doesn't help when just a couple of people like this do it. Anyhow, ton of people joining. Catch up on the latest news. So here are the announcements. They're also using champions. I really didn't know about this. I'm using language champions. Just some incentives. Nice. How did we know about this, guys? And why didn't we know about this? Nice. 5-hour live stream. Hold my beer, guys. Hold my beer. 5 hours. That's just a warm-up. Are they even working hard? Are they even trying? So this started in May this year. So this is how it got started. Looks fairly active. And then there's a ton of languages. Let me go to Serbian quickly. European, Serbian. Curious to see whether there is anyone who is from Serbia actually here. I actually saw this post on LinkedIn. Hi Zvezdan. Guys, what do you say about organizing a datathon for Serbian or multiple languages in general in our server? We could do something like that. Collect a ton of data. Let's see what our priorities first are. Okay, maybe you know some tech influencer from Serbia that we can write. Okay. Fun. I wonder how is the situation with other lower resource languages like Bulgarian. I wouldn't be surprised if it's similar. Yeah, it's very similar. The thing is, for these, you can't. It's very hard to force an effort like this. There's a couple of people from Cohere who are pushing this, but you need to have friends and people from that country who organize and understand the value and. Okay. Okay, guys. Let's quickly see how they introduce people to the project. Let's just skim this. Prompts. So here's how they collect data. You have the prompt. Look out for correct grammar, reasonable length, clear instructions. What is the meaning of the Islamic name Musa? Speaker of God. Completion, and then thumbs up, thumbs down. Prompts and completions. Think of these as questions or requests you would ask a language model or AI assistant. Rate model performance. Contribute your language. Okay. I want to submit an article. No clear instruction. Poor spelling and grammar. How to make a fire? What is the best way to make a campfire? Why? This is a legit instruction, guys. Come on. I should be able to talk with model in dirty slang languages. In the dialect. Okay, just giving them when a prompt or completion is bad, mark it as switch to edit mode. Rewrite so that it is good. Submit feedback. Structured as instruction and response. Don't use another model. Which of the following are Chinese martial arts? Completion. Some good examples. Review user feedback. Is the edited improvement improve the... This is interesting, guys. I don't know about you, but like this data collection instructions, and this is always fun. I remember back at Microsoft when we had to provide these to our labelers. Improve the quality of completion, answer with reasoning or explanation. Check whether the context given as input to the model is complete or useful by double checking Wikipedia or relevant source. Similar step can be applied to the completion. Avoid fancy quotes and use the regular ones, particularly when copying texts from external source. Solid and complete text completions, lengthening the answer or text completion to be more conversational. Writing full sentence to provide more context using monolingual prompts. Start contributing, provide UA feedback, video tutorial. We're gonna watch the video as well. Start contributing, provide the feedback, video tutorial. I think I opened up this one already. Let me see. Maybe not. I have something. It's not the same one. Okay. And then I am in the site, Discord, blog post. I think I've opened this one as well. Introducing, yes, I've opened up this one. I'm gonna check all of this. I really want to understand the project a bit better. Cohere for AI. Get started here. We support sign up using only Discord. Just explanation of the UI. Guys, you know what we should do? We should create, like, we should gamify this whole experience. This is boring. Who wants to spend time like this? You need to gamify this somewhat. Is anyone here, anyone knows how to write games? Anyone has any experience in game development? That would be amazing. We could somehow build this in the form of a game. Leaderboard. It's still not clear what's task 1, what's task 2. Clear instruction. Okay. Rate model performance. Rating model performance. So they're rating human performance and then model as well. Now, these instructions should not exist for every language. So it's still not clear. What's task 1? What's task 2? Is it clear? I don't see a mention of task 1 or task 2 being explained here. Rate model. There are 3 tasks. Okay, I'm blind. Rate the model performance. Look at existing prompts and completions and determine if they are good or not. If they are bad, edit. Contribute your language, add prompts and completions in your own language, and review user feedback. Got it. So this is kind of the 3 different tasks. Contribute your own language. And then review. Got it. Here's the team. I know Sarah. I don't know the other guys. Max Bartolo. This guy sounds familiar. Team 2. What's team 1, team 2? Team 3. Team 4. Regional leads. Language ambassadors. Analytics. I think that's the diagram we saw before. Nice, nice, nice. Cool, cool, cool. There is a blog that they introduced this. Open science project that aims to build a state-of-the-art multilingual generative language models that harnesses the collective wisdom and contributions of people from all around the world. Cohere for AI is a research lab that seeks to solve complex machine learning. We're honored to introduce Aya, Collaborative open science endeavor aimed at building a multilingual language model via instruction tuning. Year-long open science initiative brings together experts from academia, industry, nonprofits. Okay. This is just reading No Language Left Behind just from Cohere. Much of the data I used to train comes from internet, which continues to reflect the composition of early users of this technology. 5% of the world speaks English at home, yet 63.7% communicates in English. I didn't know there's only 400 languages with more than 1 billion speakers. Okay. I didn't see this market, like, I didn't see any heavy marketing of this from Cohere side. Learn about Aya. I guess that's the blog post. Climb the leaderboard. Watch this video to get started. Join the events. Prizes. FAQ. Similar to Bloom. Okay, there's a couple of videos here. This is just literally a walkthrough of the slides we've seen, so we don't have to go through this one. Can you guys hear this if we watch it together? I guess this is mostly from people who are just contributors. Let me quickly just hear this part about the leaderboard. Can you hear this? If not, I'm just gonna send you this link quickly. Let me just give me a second. Let me try and connect my headphones. If the sound becomes weird for you guys, let me know. Let me just connect my headphones. Bluetooth. Connect. Looks like I'm connected. But I don't hear anything. They did gamify with leaderboard and prizes. Yeah, they did, but that's like the most basic thing you can do ever, right? I think you can make it fun. That's more like on ego gamifying. I want to make it fun as well. That makes sense. Connect. Please connect. Give me a second, guys. Let's try Bluetooth. We are in 2023. Getting Bluetooth to connect is AGI complete. Okay, guys, I'm sending you this video in case you can't hear it. I'm just gonna quickly skim this part. Just want to see what's this leaderboard. What did they say about leaderboard? What would be super cool to do here is if we made it in somewhat that we can do like a revenue split, and people can, the more you contribute, the more you actually get some money. Like you can treat that as also as a gig. That would be cool. That would make many people want to contribute just to earn a bit of money as well. I think Stability might be doing some type of revenue sharing. That's super cool. Let me see. I'll share the link with you. Okay, that was enough. Let's go back here. I'm waiting for Chris or other guys to tell me more about this, because I never heard of Aya so far. I think that was enough. Now we can go back to doing some serious work. Okay. I want to check out these two. In the last stream, we saw that I started training, and then we noticed that there is only a single shard for English to Russian and for Turkish to this language that has the EUZN code, whose name I have to learn ASAP. Probably Uzbek. Arabic normalizer. What's the USN code? USN Uzbek. Okay, it's Uzbek. So because of that, I need to quickly revisit. How resourceful the languages are. So let me just quickly run our analyze script on our data. Let's go to the, we're in Stopes. No, that's not it. We need Fairsac. Let's find data, modeling, data, analyze data. We just care about number of sentences. for all languages, and then we want to run this with analyze data config. Let's just see whether something changed. Analyze data config, train data sets, that's all same, verbose, length vectors looking good. Let's run analyze data, hit run, wait a bit for this to happen, and let's see why are some of these languages that we picked so low resource. I kind of thought that English to Russian is higher resource than it turned out to be. Almost there. Okay, let's go. 94 languages, blah, blah, blah. Dump this. Line lengths. Let's go. Let's plot this. Okay, this is more for which languages are high resource. We can see again English, we can see Turkish, we can see Russian, and this is probably Uzbek. No, this is Kazakh. Okay, but we care more about directions, so let's see whether we'll be able to get the top 10 directions. Aha, so you see, English to Turkish is one of the top 10, Turkish to English, Russian to Turkish, Turkish to Russian, Kazakh to Russian, Russian to Kazakh, English to Hindeva, English to Tamil. So we literally didn't pick any of the high resource directions. So what I need to do is remove English to Russian and include English Latin to Turkish, and Turkish Latin to English, which have the same amount because I guess just symmetry, and then Russian to Turkish, Turkish to Russian. Why is Turkish so present here? Russian to Kazakh, English to Hindeva. Okay, English to Tamil. So I really want to include this the Hindi and English to Turkish. Maybe these two. Okay, let's include. Copy this one and this one. Okay, so let's go quickly prepare Flores. Now we've built up the muscles. We can do stuff very, very quickly because I know how to use everything here. We can super quickly do all of this. Let's just go to download script. Let's go down there. Let's go and specify, instead of English, Russian. For some reason I picked these languages. I have no idea why or how. These ones are what we care about because they are high resource, and we just want to quickly see whether we can learn any language direction for now. Okay guys, so we want to train on these two and test on these two and see whether we are managing to learn. Maybe English and Hindi are not the most similar of languages in the world, but we should be able to learn it with the amount of sentences that we have. Let's go. Let's run Flores. Again, we are here, eval, Flores dev, Flores test. We previously just kept these two. Now let's run again. I can maybe delete both of these. We can easily reconstruct them if we want. Let's just run Flores. And eval. I should just hard code all of this. Okay, here is the eval. Let's go back to download. Let's go and run this. As easy as that, guys. Just select this, run, hands off, F5. This will run and prepare our data, and we can continue. Okay, let's see. Eval, Flores Dev, English Hindi, English Turkish. Guys, this is just, we found out immediately what are the languages that are high resource, and then a couple of seconds later we have those in Flores. That's it. All of the previous 12 days of working hard paid off. Let's see how many sentences we've got here. Okay, this is just Flores, so 900. What I actually wanted to see is the value. I want to understand quickly the number of sentences, but not the log scale, but just like regular scale. Where is the log one? Just a second, found languages. Let's go here. I just need the breakpoint there, and then we can grab the non-log values here. Run. See how many sentences we have here. Whoops, wrong config. Analyze, retrigger. Okay. This is job related, by the way. I just can't share my DMs. I would if people allowed me to, but then I don't want to push it too far. My life is open source. That's how you know you're truly open sourcing a project. You're open sourcing your life as well. That's the okay, and then let's just sort this. Log values. Let me just do this, but we do this, and then key log values first 10. Okay, here are the numbers, guys. For Turkish, Latin, no, we don't care about this. Stop. We care about directions, right? Okay, let's repeat this. Temporary, and then this, and then this. Okay, here it is. English to Turkish. There is 35 million sentences. That's a lot. That's a lot. I don't have a good feeling for how much we need to learn to translate, but like with 35 million, I'm fairly confident we can learn this. And then we have, I'm so hyped up. I really can't wait to have this training running, and then we're gonna have it directly in Discord, something similar to what Midjourney is doing. You can just do like translations, people can play with this. I'm hyped up. And then let's see, the second language we picked was, English Hindeva, which is 3 million. Okay, so English Turkish and English Hindeva. Russian to Turkish Turkish to Russian, it drastically falls down, but okay. So we have again 35 million, almost 36 million for, let's just write it down into our notes. Okay, so let's write it down. Our first run, 615 million parameters, 2 directions only. That's going to be again English Latin script with Turkish Latin script that has 36 million sentences. Primary data only. And we also have English, Latin, Hindi, Deva, and that has what? What did we say? How many sentences we have there? For English, Latin, Hindi, Deva, 3 million. 3 million. 3 million sentences. Primary data only, which means we have high quality, fairly high quality data there without dealing with mined data at all. Okay, that's gonna be our first run, guys. That's gonna be our first run. How prevalent is actually English Russian, English Latin to Russian, oops, not Latin, Cyrillic. Wow, like only 3,000 sentences. Crazy. Let's stop this. Okay, that was the first step. The second step, there's one more check I have to do before we trigger this run, and that's to understand why are we deduplicating anything in the prepare data stage. Again, guys, just check if you don't know all of these terms, go to GitHub, go to my GitHub, go to the Open NLLB project, and go to the Getting Started section. Here is everything you need to know to get started here. And you'll find everything I'm referring to. Data preparation stage, model training, everything is written down. I'm gonna paste it down in the chat, check it out. If you haven't already, it's in the link in the live chat. Okay. So, let's see. We have the raw data. I want to kick off, while we're doing this, I want to kick off these 2 Flores data sets that we did not process. Let me just think how we can do this. Okay, let's go to Stopes. We just first add a to do. Process the 2 new validation directions that we can kick off our run. Okay, let's go to Stopes. Let's go to filter.py. Where is our filter function? Prepare data, filtering filter. Okay, so to the best of my understanding here, filtering, we go and we basically split this according to directions. So here we go, as you can see, all directions, we chunk directions, and then we run filter group with a certain set of directions, and then there we go and we load the data sets. If direction is not in there, we skip. Okay, so then we just go for all those directions and we do the following. We collect the data sets from the corpora. Just a quick thing I need to double check. I'm trying to basically understand whether we're doing filtering per language direction here. If that's the case, then I don't expect any filtering to occur any deduplication to occur in the prepare data stage. So we go through the data sets, which we loaded from the corpora file. group name. Where does the group name come from? Comes from here, train primary. Okay, train primary. So we grab the train primary. So we load all of the data sets. We iterate through them, but we only focus on particular directions. And then if this is not none, included corpora, which it's not because we have our filter configs and we have our included corpora. We have a ton of included corpora. Here it is. So that means this is not none, and then that means we go for corpus in corpora. If corpus name is included, then we add it. Okay. So we'll literally add all of the corpora for this direction here. If it's not none, if not grouped datasets, if it's empty, then we continue. Otherwise, we submit it here, datasets. Filter, and it literally says filter direction. It says filter direction. So that means we go through the corpora for that direction, and we literally filter here, always with the same filter. Here it is. So for filters, filter line. And this particular filter is from filters, which is allocated only once for this direction. So I'm expecting complete deduplication per language direction to happen in filtering stage. Okay. Now, if that's the case, we should be comfortable asserting in prepare data. So let's go to now prepare data. Let's go to prepare data script. Here it is. So we have this component called dedup sharding. Okay, dedup sharding. If we enter there, language direction train datasets, we expect only one to be there because we concatenated all of the corpora for that direction. Okay, I know this code now, it's literally a part of my brain. So lang direction train datasets. So we pass in that data set for the dedup sharding job, and then we pass in those data sets to dedup sharding here. Okay. So this guy will run, initialize scene, eval, go through the train data sets, enter, append. Where does the filtering happen? The filtering happens here, guys, already seen. So where does that happen? That happens for, let's see, already seen. Initialize all the scene. Wait, dedup sharding, let me just think for a second, guys. Is this like global? No, this is completely like a global filtering set. Wait. So this object run dedup sharding object. Just a second. So let's go. So this dedup sharding is going to be created for each of the batches. And then we schedule. Then we schedule it. Then we schedule it. So if we enter here, you're created once and you initialize the scene. Why would you? This is weird, guys. This is weird. We go here once, we initialize it, and then we go through all of the training ones. We iterate through the shards, through all of the shards. We go through all of the shards for this particular data set. No, I mean, we create the shards. We create a ton of shards here. And then what do? We open the train dataset source. We open the target. We go through the lines of this dataset, which is, again, this is a concatenated dataset across corpora for a particular language direction. So we go here, we randomly pick a shard. If we have not seen this already, then we write it. So it's doing deduplication. If it's not already seen, just write it. If it's seen, we skip writing. So what this might do is, because it's always the same, it's keeping the same set. If we have two directions, if we have like English to Turkish and Turkish to English, which are the same, it's gonna filter out one direction completely. I think that's how this is gonna work, guys. Already seen. If it's not already seen, so it's gonna normalize, do its thing, and then add. We should be running this initialize scene literally for each target direction, but for some reason we're not doing that. So this is doing this is doing global data set across all directions, global deduplication. Global deduplication. Would love to test this again. Okay. Okay, I have a small to do there, but we can ignore that. Let's push through. Let's just push through and start our run. It's actually not going to be a no up, and this as like a second order consequence, because of this batching I've made, I effectively reduced it from not being global anymore. It's not global. It's going to be only applied per batch. Okay, let's process these two new directions and let's kick off a run, guys. We don't even need mine data for this first run. We don't need mine data. We don't need curriculum learning. We don't need to estimate the compute. This is all for a bigger run. See whether prepared data is processing batches according to. Okay. This is the main thing. To run our first, to train our first model. This is just full. We can just figure out this later. Sample text during training. I want to sample text during training, and I want to have sacred blue or something like that to measure some metrics other than loss. Okay, we are close. We are close. We are close. We are close. We are super close. Let's run. Let us prepare the validation data. How can I run this without messing up the previous run, which is in the processed new, which is going to be here, prepare data. Here we have some data, we have some shards. I would love to go to prepare data, change this again to, we said what? We said English to Turkish Latin, and we said what? We said English to Hindi Deva. Flores, nice, that's cool. Dev, we just need to change this to English to Turkish, Latin, English to Turkish, Latin, but this is gonna be Turkish, Latin. Okay, looking good. English, Turkish, English, Turkish, English, and Turkish. And let's modify this one. So here we're using English, and here we're using Hindi, different script, different language. It's going to be English, and this is going to be Hindi. That's it. We've updated our data sets here. For train, we don't even want train. We just want validation. Let's see whether that's going to work. I really hope. Partition, all of that is good. Prepare data, final data. No, not really. We want to go to this guy. Okay. Process data new, that was the last one we kicked off. Do I want to change anything among the different configs? I don't think so. Vocab remains the same. Sharding, nothing needs to change there. Processing, nothing needs to change there. Nothing changes, guys. We just kick off this run. My only concern now is if I try, so I'm trying to reuse the previous work so that we don't have to recompute the training data. I just want to process these two new validation directions. Will that happen? If I just trigger a run, will I be overriding anything? That's my concern. Well, there is one way to find out. There is one way to find out. Train corpora. We can comment out this for the time being. Well, actually, train, yeah, we commented out corporate train. So we need to comment out this as well. Okay. Kick it off with no arguments. Let's go. Interesting, we're entering here, but only if it does not exist. Let's go. Run. Prepare data new. This was not touched because everything it has done is ensured that these exist. Grab datasets, save this one, and we're now running. Let's go. Let's enter the validate stage. Let me just make sure there is nothing that will be messed up here. If we go and trigger this, if I run this, will this mess up anything? Does not look like that's the case. It's just doing some validations there, counting the lines and stuff. Hit it. Oh, that was fairly quick. Let's go. Let's go. Let's go. Maybe sort. Datasets with metadata. We only have two. We only have two. We don't really care. It's just two datasets, guys. Let's go here. We process them. We put them into the fold. Validation. Nice, as you see here. Let's go. If this is none, we grab the data. We go to here. Let's just make sure this will not mess up with anything. Hit F5. Let's go. Run. Exactly. Nothing happens there. Concatenates the files. Huh. Okay, there is just a single data set here. So there is no concatenation that's going to happen. Let's see whether we got this to retrieved. Retrieve data. Did we get the validation for these two? Let's see, validation, English, Latin, Russian, English, Latin, Turkish, exactly. Here it is. And finally, we are waiting for one more. We don't have metadata, we can just retrieve. Nice, nice. Feels so good to understand the code base nicely. Everything is just so much smoother than before. Hit F5. We do the same thing for this. So we're waiting now for English and Hindi to appear here. If I just hit F5 here, we'll soon see, as you can see here, English, Latin, Hindi. Here it is. Awesome, awesome, awesome. And because these are just flores, nothing gets concatenated. There is only 997 lines. We can continue. This is going to be a very fast iteration through the whole pipeline. Prepare data. Let's hit F5 and then here. Hit F5 and then here. No, wait. What happened here? So it's expecting me to pass in some train data. It's expecting some train data, and I'm just trying to incrementally add 2 validation data sets. Okay, stop that. Go back to prepare. Let's rerun this. Should be fairly fast. Hit F5. Okay, we are back. We are back. Vocab, this one will work in OF1. This one is the problematic one, apparently. If we manage to somehow modify it so that we can incrementally add 2 Flores validation directions, that would be amazing. Hitting F5 to enter here. Sharding config. Train count maps empty. Max number of shards. Okay. Actually, this won't do anything for... Got it. We can skip completely this complete phase. We don't need this stage. This stage, the only thing it does is it uses eval data to dedupe the train data. So you can see here, we go through the data sets, grab eval, and then we trigger this. The eval data sets will just be from here, and that's just going to be appended from the retrieved. Okay, so this is just like retrieved data sets. Retrieve data sets. So we can shortcut and completely comment out this whole component. That's a hack we can do, just to process incrementally Flores. We append, and then we pass that back in. Not caring about the language, just about the data set. Okay. That's the solution. Go to prepare data, and basically comment this out, and instead retrieve sharded train should be none. Retrieve the eval and number of shards. Will this complain if we just pass, if train is empty? If train is empty, then nothing happens. This should work. Okay. Let me quickly remove this. And thus remove this. And then specify this as empty. and specify retrieved eval as just retrieved, and this set to 1, and this is now equivalent. Nice. This should be equivalent to the original run. We're just circumventing the fact that we're not passing in any training data. We just want to pass Flores. Okay, kick it off. Get to here. Let's see whether this await getter does not crash because we have a single function here. Not enough values to unpack. Let's just remove this. We don't need getter. We just need to await this one. Now it should work maybe. Let's see. It does work. Retrieve data precisely like this. Dedup sharding. Let me just see that. Make sure this makes sense again. Sharded train. Eval train is empty. And max number of shards is basically, unfortunately, this is only for training. Okay, let's enter binarize stage. Hit F5. This should be empty. This should be empty. And these two should have source and target. Source should always be English. Retrieved value blah blah blah. English, retrieved, English. And these should be Turkish and Hindi. Exactly. Okay. Next up we do this. Binarize number of workers, output directory. Output is going to be precisely here. Looking good. And now this is not looking good because we're going to skip the for loop because eval is empty. Let's instead pass in this. We're just hacking. Let's run. We are hacking, but we are keeping the equivalency. Everything's going to be equivalent. Let's go. And what happens if one is empty? What happens if you pass, you binarize a function, you pass empty fourth argument. Empty shards. If shards is empty, then you enter this one. Shards. Wait, how did they come here? Just a second. So get here. Shards is passed in. Is passed into this one, which is this one. Okay, and then what happens? Again, going back here. And then what happens is in the run here, assert that the input file exists. Okay, let's kick it off. Okay. Chunk it up. offsets. Okay. This is for what? Which direction is this? English to Turkish. This should be very, very rich direction. Only million, no, 126,000. Why? Okay, hit the 5. This should now store in the temporary directory. If we go to prepare data new, temporary, binarize, here it is. We have validation. English, Latin. And this one is now going to be moved here to shard 0. Validation somewhere here. We currently don't have it, but soon we will see among all of these validation ones, we're going to see also those directions. Let's see. Merge results. Let's open up shard 0. Oops. Sorry. I'm expecting to see new validation here. So English, Russian, English, Russian, English, Turkish. Here it is. Here it is. English, Turkish. We are there. Hit F5. Okay, there is a new one. What's this input file? This one is Hindi Deva. Hit F5. Hit F5. This one is English, Turkish, but this is the Turkish. Okay. And the last one. And the last one is, whoops. Exactly. Run, run. Once this is done, we exit here. We are done. Nothing here. Nothing here. And we might need to do what? Okay, we might need to fix the sim linking. That might cause us some issues, but we are otherwise done, guys. We are otherwise done. Otherwise, we are done, completed. That's it. We have our data. So in shard 0, as you can see here, we have the English, Latin, Hindi, Deva, these two, this one, this one. This is our new direction. And this is also our new direction. So that's our new data. So now we can run on these two directions, our training run. My only fear is that we skip this sim linking, which does what? Which grabs the original path then grabs the target path and sim links it. But we don't have, wait, we don't have, yeah, we don't have more than one. We never, I think we're good. That's all I'm saying. Process the 2 new directions so we can kick off a run. Okay, let's go back to the run. Let me go back to the run. We have to change to fairsec for that. We have to go to the train.py inside of the fairsec CLI directory. Let me just close down some of these. Fairsec CLI train, here it is. Let's go to our train setup. Here it is. I have taken some time this morning to analyze what each of these arguments does. We are mostly done. There's a couple that we don't understand. We understand most of these arguments, which is good. And now I want to change the languages. And that's going to be easy because, well, we understand how stuff works and we've just processed 2 new language directions that we care about. One of them is English, Turkish, Latin. The second one is going to be English, Latin, Hindi, and that's it. That's all of the modifications we need there. We don't change anything here. We keep max tokens because otherwise my computer glitches completely. Unfortunately, unless we modify FSDP somehow that we reduce the memory consumption, I can't go more than 2000 tokens per batch, which is a small number. The original training run used 1 million, just for like comparison. Okay. All of this is good. We might want to change the temperature, guys, because otherwise we have a, as you saw before, I'm not sure by how much, but we need to change it. Currently 3 million and 36 million for these 2 directions. If we just leave the temperature at 1, because of this disbalance in our data set, we're gonna mess up. So we need to change this to some number. I have no feeling for how much we need to change it, but let's just put that as a to-do. Oops, checkbox, modify the sampling temp because of the imbalance between 2 directions we care about in this run. Just make myself aware that I don't forget that. All of this is good. Let's skip this for this time being. We can ignore all of this. We can ignore all of this for now. Optimize our arguments, we can ignore it. This is good as well. So we're good. We now, let's just quickly understand what these do. I kind of understood what this one does, but not completely. So I'm going to put it here in the distributed setting. And then these 2 are kind of unclear. We can move this one. Replication count. Understanding this one will help me to increase the maximum tokens because currently, as I said, I'm limited by my VRM and FSDP setting. So replication count. Let's understand these 3. Let me put my notes here. And let's go. Okay. Once we understand these 3 arguments, we can kick off a run. We might need to, there might be one more thing we have to do, and that's to figure out whether we are sampling text during training. How do we track how our machine translation system is running? Electricity bills, here I come. Skip invalid size inputs. This one we need to understand a bit better. Again, let me just see where is it mentioned in the code base. Skip invalid size inputs for the validation and for the test. I think that one just helps us ignore too long sentences. Aha. Yes. Yes. Let's put a breakpoint here. I'm fairly sure I understand what that one does. Just filtering by line length, basically. Let me just quickly do the underscores here just to see what other references we have in the code base. Whoops. What other references do we have? Ignore invalid inputs. Ignore invalid inputs. It basically always specifies the ignore invalid inputs inside of the dataset task batch iterator. Ignore too long or too short lines. What's too long and too short? I guess that's my question. Because we filtered using 5 and 1005 in the filtering stage, we want to make sure those are the same. They're synced between our filtering pipeline and training, if that makes sense. So because of that, let us go to trainer. Let's see. We can ignore all of this. We can ignore this. We can ignore this. We can ignore this. And let's put a breakpoint here as well. Okay. Whew. Let's see this one. 2 more arguments to go. Only 2 more arguments to go. By the way, guys, have any of you been to the event today with Nils? If so, let me know how you liked it. Use local shard size. If true, use the training dataset size of the current shard only for sampling distribution. Okay, I think I now understand what this is. So this is for when we are picking which directions, how much data we want from each of the directions. This one just looks at the local shard. That's all it does. Use the training dataset size of the current shard only for sampling distribution. That's how I understand it, guys. Let's just see. Once we put the underscores, multilingual dataset manager, and here it is. Yes. Okay, that's the second one. And finally, replication count. This has something to do with FSDP, not completely clear to me what, but I'm gonna find out soon enough. Let's just put replication count underscore. Is there any explanation what this does? Any explanation whatsoever? Replication count. It might have to do something with mixture of experts model, but I'm not sure. So until we see exactly what it does, we don't know. Replication count, paths to load, checkpoint files count, if world size bigger, return local path. You can put a breakpoint here. Replication count, paths to load the checkpoint. Something to do with checkpoints, but I suspect replication when loading mixture of expert states. Okay, if we remove pi here, let's see what they mention about it in the, okay. So you can see here mentioned for mixture of experts again. Yes. That looks like that's only used for, definitely looks like it's only used for mixture of experts models. I don't like they're calling it just replication count. Not really intuitive. But it is what it is. Okay. Let's kick off the run. Hopefully we'll analyze these three parameters. And then, as I said, we need to see how to sample text during training easily and log that. And then we can kick off the run and just watch it burn my electricity. Then we can in the morning see how it went. Hopefully no crashes. Hopefully we get some model that can actually sample text. We'll probably have to port the checkpoints to Hugging Face, by the way, to do the generation step. I'll have to write that code, or somebody can from the community can also help. Okay, enough rambling. Train. Let's pick the right script. And let's kick off the run. Okay. Let's go. Let's enter here quickly. Enter. Okay. Using the local. Let me see the log here. Nice, look at this. You can parse everything, right? Let's see. We can remove this one because it just notifies us, nothing else. Okay. We can hit run again because this is the same thing. Just run. This building sampler, what this one does is, okay, we have the breakpoint here. Let's go. Running load checkpoint. Okay, I think we stopped this because of checkpoint. Use local, skip invalid, ignore invalid. Yes, this one is picked because of replication count set to 1. Let's enter here. Replication count. Where are you? Here it is. Okay, why do we have a checkpoint here? Because data selector, trainer, load checkpoint. This is gonna load the training data. Is there any ignore invalid inputs? Ignore invalid inputs. Let's check this one. And then the second one is use local. Okay, that one does not exist. Replication count. That one does exist. Hit run. Okay, here we are. Now, because this is set, we go here. Okay. Load dataset, get train. So we are loading the train split. This is obviously a train split. Load dataset, load dataset, get sampling ratios, get sampling ratios, get train dataset sampling ratio, number of shards, 28 and 11. Yes, that's it. That's for English. That's for English Turkish and for English Hindeva. Awesome, that's great. And then they grab the dataset sizes. I'm not sure why we get precisely these numbers. How does one get these dataset sizes? Where is this specified? Where do you populate this? $1 million. If local. Aha. Okay. This makes sense. We have how many shards? 28. I suspect this is currently dealing with English, Latin, Turkish. Let's see. English, Latin, Turkish. Okay, let's multiply this number. 1,256,000. Let me take out the calculator as a good large language model that I am. 1,256. Oops. 000, let's say, roughly. And then how many shards again? 28. And that should be equal to the number we've seen before, which we expect around 36 million. And that's indeed the case. Small rounding error because I use different numbers, but we now completely understand what's going on here, right? So if use local shard size, then you just grab the local shard size for that particular direction and you append it here. Awesome, awesome, awesome. Makes sense, makes sense, makes sense. We do the same thing here. Again, this should be 234 times the number of shards, 11, that's roughly 3 million, right? So if we multiply this number, let's just be completely, so if we multiply this number, 234,631, multiply that by 11, right? That's around 3 million. For some reason, a bit less data here. Did we lose any data? Yes, well, we had filtering, right? It cannot be the same completely, but that's it. Now I'm much more confident that this makes sense. Okay, let's exit, let's return this back. And now that we have this, now we enter the sampling method. Awesome, okay. So let's see. Let's enter here. Let's enter here, let's see what's gonna happen here. Let's hit F5. Here we are. And let's see how big of a disbalance we'll have here. So if we just run this as it is, we get 0.84 and 0.15. That means we'll be sampling much more the English-Turkish direction as opposed to English-Hindi. If we change temperature just slightly, like if we maybe go and say 0.7, just temporarily, let me think, if we reduce the temperature, what do we do? If we reduce it, wait, does the reduction of temperature goes towards uniform or vice versa? Let's just see. If we run this, then we get this. Okay. If we go and put it like to 0.2, very low. Okay, now it's messing up this. Let me see temperature. If we go a bit higher and run this, okay, this looks better. So we want higher temperature. Higher temperature is going to make it easier. It's going to reduce the peak of this one, and yeah, higher temperature basically goes towards uniform. So if we put like temperature 2, this will be okay. Closer and closer. Okay, we can maybe experiment with that setting a bit later. But for now, important thing, we understand precisely what this argument does. Let me go to launch JSON. Let me grab this one. They could have at least mentioned sampling somewhere in this argument. It would have been so much easier. So it's literally, its place should be here, literally next to this one. Okay. We still don't know what replication count does, nor this ignore invalid inputs, so let's figure that out. Hit F5. Here is the ignore invalid inputs. Let's hit F5 and enter here. What's this one? Ignore invalid inputs. What does it do? Don't raise exception for sentences that are too long. Default is false. Aha, so we raise exception. If it's ignored, then we just ignore it. Okay. But it has to do with length, as I said before. If it's round robin, then do that. Otherwise, let's just enter here. Ignore is the second argument. Here it is. Okay, this one just returns this function. And then blah, blah, blah. Let's put a breakpoint here. Here we are. Max position is 512. We have our data set, which is, we are in the train iteration. So this is a train data set. And we have some indices. Okay, and then filter indices by size. Okay, ignore invalid. Aha, so if length of ignored is non-zero, if not ignored, we raise exception, otherwise we warn. Okay, that's it, that's it. Size of the sample is invalid since max position is 512. Size of sample number, and then dataset size of that index is gonna retrieve us the length, I guess. Okay, let's see what this does. What do we ignore? (20 and 16). What's 20 and 16? Aha. Okay, these are the lengths of our sentences. Got it, got it, got it. Makes sense. So now we do the filtering by size. This is the max size. These are the indices and sizes. Okay, enter. We can just quickly see this. Ignored are which ones? Those ones that are bigger than max size, or those are bigger than this? Do we have ignored? Yes, we do. One is ignored. And we get its index. Just a single one is ignored. And then because it's ignored, if we didn't ignore, we would raise exception. Okay. Makes sense. Let me update the launch.json. We understand what this does. Basically, again, this is data related. This is a data related argument. Okay. And the last thing is replication count. Let me just see quickly. I'm fairly sure that the paper mentioned temperature as well. They did upscale, they did upsample something. Let's see, temperature. Not a lot of times that they mention it. Okay, we experimented with multiple settings of temperature upsampling for underrepresented, where sentences from language L presenting PL% of the dataset are sampled proportionally to this. Optimal performance was obtained at 0.3, which means what? 3/10. So temperature has to be above 1. 1 over 0.3, 3.33. But this is for LID training, not for... Sampling temperature 5. What's this? Modeling. Okay. They only use 100 million sentences, and we're about to use 30 million just for a single direction. We sample a total of 100 million. This is for training the sentence piece. Okay, this is again. Okay, results. Yes. Okay, so they do use 1 for actual training. Okay, yes. Our baseline is a dense model trained for 100K updates on MMT with a sampling temperature of 1.0. Okay. This is again tokenizer. For tokenizer, they upsample. Okay. That's what I wanted to see. Go back to notes, replication count, and we can kick off the training. Maybe we can change the imbalance just by a bit. Let's go back. Run. Replication count. Is that the only mention of replication count in this whole file? Yes. And hit F5. Replication count. Just run. Run. Let me see what we're gonna get here. Okay, same. Okay, let's see what's gonna be a reasonable number here. If we put like 2, then we might overfit too much. It's not that easy of a trade-off. like just one, then we get too big. Maybe we can try 1.3, like, I don't know. Okay, continue. Sampling ratios. How are the sampling ratios used? Do they apply? Do they normalize this later? I hope so. Probably softmax. Okay. Hit F5. Run. Remove this. Run. Remove all of this. Build the optimizer. We don't care about this anymore. Where are we not hitting? Where are we not hitting that? Okay, my computer might start glitching now because I'm running a training. We still didn't hit the replication count. What the fuck? Why? Stopping. Putting this to 1.3. Stop the training. Okay. Just one last one and replication count. Just focus on PI files. Please show me where. Train script. Checkpoints. Okay, probably once we get to the point that we have checkpoints, then in that moment it will start hitting these. That's the thing. Which means it doesn't have to do anything with okay, it doesn't have to do anything with okay. That's it. We can safely ignore that one as well. That's for mixture of experts, just during the loading of the checkpoints. So replication count set to 1. I can maybe make a comment here. Okay. Now, guys. How does one, what do we log? Now is the moment to see what do we log during the training. And once we found that out, if needed, we're gonna sample and store the sentences somewhere and see what we do. How often do we do the validation? Let me see here. The validation interval is every 1,000, okay? So I'm curious to see what happens after 1,000. Maybe for now we can reduce this to like to like literally 200. Just so that we can see immediately what happens there. And okay. So our goal now will be to understand exactly what is being logged during the training. Okay, so for that train step, I guess. Yes, apparently. Train. Okay, here we are. This is our main function. This is everything that we need. Disable, well, we don't want to disable all breakpoints. Let's just put this one here. And we're gonna make a short break, and then after the break, we're gonna continue and figure out what exactly is being logged. Once we know that, we kick off the run. During the night, it's gonna run for 10-12 hours, and tomorrow morning, we're gonna analyze the results and see whether the SEM, and then we're gonna take some of the checkpoints, put them, and try and generate the translations and see whether native people who speak Turkish or Hindi. So if you speak Turkish or Hindi, please check out the Open NLLB channel and join for tomorrow, because we are going to be testing these models if we manage to train anything serious in like a single night. But yeah. Oh, nice. This guy says, happy to chat more about it. I'm one of the Malay ambassadors for the project, but over at Aya isn't the main focus. We are curating monolingual resources. Nice. Let's see what Chris says. I've been talking with them for a while, but they haven't clarified their license policy. I see they did mention similar to Bloom, aka Rails, was it? They're aiming for open permissive, but they include Rails style into open, which is not good. Can you dumb it down for us legal laymen? What are the main downsides? I remember Yannick made a video about it. I did watch it, but forgot the tiny print. I think they have decided on Apache. That would be amazing. Licensing. Nice. Let's quickly go through this presentation after as well. After we kick off the run. Okay. Okay, guys, quick break just to stretch the legs, and we are back in a couple of minutes. It's 11:15 p.m. in Serbia. I'm gonna be streaming probably until midnight at least, just because I missed the mid of the day stream because of the Niels talk and the MIT talk I gave. See you again in 3 minutes. Let me put a note on the Notion. And we are back. Okay, guys. Let's wrap this up. So, task analyze what is being logged, measured during the training loop. Okay. Let's see what happens here. Yeah. Okay. Let's start stepping through the training code. Stopwatch meter. Let's just quickly skim whether anything is initialized here in the code above. Okay. Nice lemonade with what's meant, I think, the plant. If anybody cares. Just saying. Metrics reset. Let's see here. Set up the task. Distributed training. Logging. Loading dataset. Building the trainer. Loading the checkpoint. Stopwatch meter that I assume just measures time. Computes the average sum duration exactly. So that's the time measurement. Okay. And then it starts here and then we enter. Okay. And then we train and then we step and then we grab and then we stop the metering and then we say train meter sum. Okay, and then we write okay, so basically everything interesting happens here. Let's put a breakpoint there. Let's run. I already feel more and more comfortable going through PairSec. That's nice. That's a good sign. We're making progress. My hands are cropped. Whew. Nobody's writing anything in the chat. Are you guys all right? Did they bore you with this? Let me put this. Did they put 1.3 already? Sampling. Yes, 1.3. Okay. F5. Remove F5. Remove this one. F5. And we're in the train. Let's go. Let's go. Let's enter. Okay. We grab the iterator. Update frequency is 1. That one controls the... Okay. Again, let's just ignore this. Let's run. Okay. Update frequency controls the gradient accumulation steps. Progress bar. Okay, this one is probably relevant to us. Let's see. Common log format, JSON, log file, log interval, epoch, TensorBoard, weights and biases. So we don't care about Azure, we care about WinDB. That's what we're gonna use. And everything else here. Okay, let me put a breakpoint. Let me open my notes. Okay, there's some serious glitching going on. Let's see, so go here. WinDB. Guys, this is taking too much of the compute. I'm going to stop this and reduce temporarily the dimensions so we can just debug this with a smaller model. Let's just quickly debug this with a smaller model. So go to transformer, let's reduce number of layers to like 6. Let's just go to 6, guys. I don't want to crash my computer while I'm doing this. Let me just add a to-do. Set to 12. Exactly. Okay. Run. Let's go and run. Hopefully this will somewhat improve the performance. Let's see by how much. Or let's remove this breakpoint. Why are we even hitting this one? Still. Okay, here we are. And this is looking better. It's not glitching anymore as heavily. Okay, only 5 megabytes. We are good. Let's enter here. F11. JSON progress bar. That's gonna be the bar. And then we wrap it additionally into the weights and biases bar. Interesting. So it's gonna be JSON wrapped into weights and biases. Enter. What does this one do? This one has a long interval and it does what? Grabs this iterable, whatever this is. Probably something from the parent class. And then during logging, performance some statistics and logger info dump. So this is the one that dumps to our terminal. Print end of epoch stats. Again, format stats and then log info. And then this one just does something here. Yeah, we can maybe put a quick breakpoint there once we enter there, or here once we enter here. Okay, having said that, let's exit. And then let's just quickly, why is this set to none? Because we are in the process that has it set to none. The other one might, the other one will actually go inside there. So if we go here, if we enter, this one will hit this and will enter as the second process. It's probably the main process. And then here, what happens here is we just initialize the weights and biases, and then it additionally does what? Wrapped bar, which is the JSON bar, calls its log, and it logs to weights and biases first, and prints logs to weights and biases, and then calls the print. So we'll be hitting this, and then we'll be hitting JSON. Basically, update config log to weights and biases does what? Here it is. It goes and grabs some prefix, precise location, and then logs stuff. Okay, let's see what it will log. I'm gonna put a breakpoint there as well. And then update config. This will now call the weights and biases. Okay, begin epoch. Let's see. With metrics aggregate, train inner. So this is going to be aggregating something. Let's see what exactly. Aggregate. Taking in a lot of liquid. Let me think. Step by step. I have no idea when this one is called, but god damn it, we're gonna find out. Oh, look at this. We are in this one. Yield the object. Okay. Interesting how that one is designed. We literally have this JSON progress bar, and when we call iterate, we call this one, and then we have the iterable. Which is, okay, here, passed in here as the first argument, iterator. So we just initialize the progress bar with that iterator, and then we go through it and yield that object. Interesting design, I really like it actually. And the iterator is just our epoch iterator with data. So we've yielded samples. So this is the data, and then we say with aggregate. Oops, that was a bit too much. Enter. Okay, so we are in the aggregate. What's to be aggregated? Nothing. And then we yield nothing. Nice. Okay, now the second process is kicked off. We can get back here. Enter. Enter. Will this one also be nothing? Yes, one giant nothing. Okay, we exit. Where are we? Why are we stuck? Why are we stuck? Why am I drinking so much liquid? I have no idea. Okay, put the breakpoint there. Okay. Aha. So we are now in the JSON progress bar log. Precise epoch. Format the stats. Aha, so it grabs a ton of stats. Epoch and then update. So what the stats are: wall, CUDA, loss, scale, norm, a ton of different stuff. Where is this called? It's called here. Wait, how did we end up here, guys? I thought we... were supposed to be here. Okay, anyhow. We got teleported. Log there. Grab the stats and log them. Train inner. Prefix. Train inner. And then we call log. Train inner. Epoch like this and step like this. And then for key in stats, if instance is average meter, then we'll log. Else if instance is number, then we'll log like this. Okay, ton of log in there. Again, nothing there is actually sample data. We'll probably be logging that in the validation. Maybe. Okay, all of them take this elif branch. All of them are taking the elif branch. Branch. Okay, and here we are. And now we go to here. And we format the stats somehow. And then with rename logger, whatever that is, we log the info here. Train inner, epoch, update loss, NL loss, PPL, words per second, UPS, batch size, a ton of different details, okay? And then we're done. And then reset the meters, get the meters. So this is everything we've been logging. Let's see what are the keys inside. Loss, blah, 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 blah. Where is this derived meter? Okay. And then we just call reset, which does what? Sets to 0. Sets to 0. What's this one? Continue. What's this one? Time meter. Elapsed time. What's this one? Again, time meter. Why that many time meters? Smoothed value. Let's see what self values brings us. Okay, nothing we can easily investigate. It would be valuable to understand what exactly is logged here. Maybe some of those will be useful to us, but it's not obvious because we just see stuff on the logging info console. By the way, if the battery dies at one point, I'm just gonna quickly replace it and restart the stream. I'm not planning on stopping yet. I'm going strong. Average meter. CUDA stuff. Okay, let's just exit for now. That was the reset. And then after that, is it end of epoch? It's not. Should we do validate? Nope. Should we stop? Nope. Let's go into the second one. Let's just run the train step without stopping. F11, just exit here. Just reset. Go back here. Just step over. For now, we're gonna ignore this. Just see what happens here. If log output is not none, which it's not, we have the loss, we have the NLL loss, we have the sample size. Okay. We enter here. We get the number of updates. 101. If it's here, oh no. Let's see when we hit this. Let's see when we hit this. Let it run, let it run. Let's see how big of a memory footprint we have with. Wow, it's still close to 20 gigabytes. That's a lot. Waiting for this to hit. So every 100 steps we come in here, and then metrics get the smoothed values for train inner, and then grab the training stats out of that, and then log, and then reset. Meet epoch stats. After each log interval, the end of epoch stats will still be preserved. Okay. Get the smoothed values for the train. Okay, let's get this and see what this is. Okay, just a ton of stuff. NLL loss, PL, UPS, VPB, all of those that we see later as keys, and then get smoothed values. What does that even mean? On an object of a type, what's the type of this object? Looks like ordered dictionary. What's the get smoothed values? No, this is a meters dictionary, whatever that is. Let's quickly see how that object looks like. Class meters dictionary. Okay. It's just a inherits from ordered dictionary. Meters are sorted according to a priority that is given when the meter is first added to the dictionary. In sort, priorities. Here is the priority. Add meter. Load, get smoothed values. grab the interesting. For key and keys. Okay. If it does not start with underscore, then call for that key the get smoothed value. So for that particular key, we grab the meter. So there is the average meter for, we have the average meter for loss. And then we grab the, what's the smoothed value for the average meter. Get the average, and if round is not none, safely round the value to, I guess, 3 digits. Oh my god. Could you go deeper into this code? We went to the very end of the parsec. To the very end. Recursive. Round. 3 digits. Yes, we now understand what the smoothed value is. Okay, exit from here before we go mad. Let's just exit from here. Let's just exit from here. Exit, please exit. Leave this place. I'm gonna die. Okay. That's it. So those were the stats. We got the smoothed values. And then round get meter default meter elapsed time. We just grabbed the the number of seconds, and we return back the stats. So those are the stats. Basically, get training stats gets all of those meters and extracts values from them. Okay, and then calls our weights and biases around the JSON bar. So now we go F11, we enter our weights and biases bar. We first go there, and that one is going to log the epoch and then go through the stats and just log all of them. Okay, makes sense. Let's exit here, and then we enter our JSON bar. The JSON bar does a similar thing. It grabs the epoch, it formats the stats, and then just dumps them. Okay, fair enough. So the fun is not there. The fun is, where do we actually set up all of those meters? I guess inside of the train set step. And what else do we log? So we have epoch, update, loss, NLL loss, PPL, UPS. I don't even know what all of these are. I'm gonna find out in a second. Just quickly see something. Okay, put a breakpoint here, enter, enter. Let's go. Metrics log start time. Priority 800, round 0. Okay, here is where the magic happens. Logging outputs. Okay, we're gonna see all of those. Let's see what we can ignore and what we cannot ignore. samples. I'm fairly sure we can ignore the sample prepare because this just converts CUDA, blah, 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 move to CUDA. We can exit. We don't care about this. We don't care about that. We don't care about that. We don't care about that. Train step. We might care about that because we might be logging something internally. Let's just see here. Train, blah, blah, blah. Okay. Criterion. I doubt we're doing anything here, but let's see quickly. Okay, here we grab the, whoops, hit F5 here. Okay, hit F5 again. Okay, model train. Let's go to here. Enter. 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 Okay. So we run the model, compute the loss, and from here we grab some of these. So we grab what's the loss, what's the NLL loss, what's the number of tokens, number of sentences, and sample size. If we report accuracy, which is false, okay, let's go back. So that's criterion. It just gives us, there is nothing being logged there per se. Backward, we can ignore that. We can ignore all of this. So train step is mostly, we can ignore most things in the train step. Wait, we only 3 hours of streaming, guys. Come on, we can do better. Why is, I guess my second thread might be blocked somewhere. Okay, just go, just exit, just exit. Let's go. So train step completely not interesting. Nothing here was really interesting. We just logged some wall time and then we prepared and then we ran this. So we just grabbed some data there. Okay. We append the logs to the logging output, sample size. Okay. And anything else interesting here? Gather a logging output from all replicas. Okay. That might be fun. Train time. And then logging outputs, sample size, OOMs, train time, and this. How does this work? Why am I so curious about everything? I need to ignore stuff, but I'm still exploring the code base. Get criterion. No, we can just exit here. We can just exit this. Let's go. Don't you die on me. Train step, we're here. We might be blocked by the second process. Let's go. Let's go. You can do it. You can truly do it. Okay. And exit. And we are here. Sync the stats. It's waiting here because this is blocking call apparently. We go and we get all of the values here, cumulative training time, logging outputs, sample size, OOMs, none, train time. Okay, and then debug done with forward backward. And then what do we do here? All reduce the gradients. It has parameters. Shouldn't this be a blocking call? Reduce grads. Weird. Multiply. Clip. Okay, as I said, this should have been blocking call. I'm surprised they didn't kick off the second process here. Anyhow, F5, let's go. TPU, check stuff, blah, 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 nothing happens there, hit F5. Okay, optimizer step. Let's see whether something happens in the optimizer step. I doubt it. I doubt it. We can go out. Out. Let's go. Debug. Just run this. And then almost done here. Log the GPU memory stats. Is that going to write anything to WinDB? Maybe, maybe not. Okay. Let me just see what this is printing here. Okay. Task languages. Language outputs. We appended something new. Okay, we appended language indexes from the task. And then we call reduce log stats, samples, and grad norm. This is where the magic happens. Let's see. Is tensor metrics log the speed. Okay, so here's where we call the metrics. This is it. This is it. This is where most of these metrics are called. And then after that, empty cache. Maybe something will happen here as well. And something will happen here, and we're done. So we just care about these metrics calls. But by everything I see here, we probably don't do the stuff that I care about here. We'll have to check the validation loop. Let's enter here. Reduce and log stats. We're here again. So what's UPS and why do we set it to 1? Sorry, let's enter here. Get active aggregators. There is a train inner, there is the train, and there is a default one. Where did we call the train inner? Where did we call the... I know where we call the train inner. Or where do we call the train? Oh, it's just annotation for the whole train step. So that's how it works. It's just annotation for the whole train step, which is called here. And then train inner is called inside of the train step itself in the aptly named train inner. Okay. And then we have what? Default. Where is the default one called? Default. Interesting. No mention of default here. Probably because it's default. Let's go. We grab the first aggregator. The first one is again the train inner or train, and then that one collects a ton of things. UPS update with the value 1. So in all of the aggregators, we update this one. Okay. Log scalar gnorm. Okay, so gradient norm. That's a very relevant metric. That's a really very relevant one that we'll need for once we start hitting any potential loss spikes. So let's see where this one is logged. Grad norm is passed here from here. Grad norm computed here after clipping. It should be 1, right? No, 2, because what's the clip norm? We don't set the clip norm. And because clip norm is not set, okay, I don't want to go into that rabbit hole, but anyhow, we have it. Log the scalar, again for active aggregators, which are again these 3, where I expect this one, priorities. It just updates, it just updates, same as the previous one. And then if clip norm is bigger than 0, then we would log the clipping, which we don't do. Okay, let's see here what happens with aggregate as. Okay, I still have to understand these context managers a bit better. I'm always a bit confused, to be honest. Enter. So I know that the enter is the main piece, and then you just hold next aggregate. Name is gonna be a random UUID for hash, and then we create this dictionary, which is just, we've seen that one. Okay, and then you add, aha, okay. So you just create a temporary active aggregator that you just created here, and you add a name, and then you yield it. And then you delete it already. What? What happened here? Oh, I hate this. No. What happened? We were here. Wait, I'm now completely lost. Where were we before this step? Okay, we were here somewhere. Gradient norm. Gradient step. Let me just grab the second process to get unconfused. Or we can just continue here and then. So log the scalar loss scale. Loss scale if FP16, then this one, otherwise, okay. So they keep on setting some priorities here. I don't know how they came up with those, but I'm not gonna, let me see, I'm gonna just quickly, let's go into this, see whether still same 3 aggregators, yes. Okay, exit. And then log stop time. Again, aggregator, and then we call for the key, the stop with the wait and pre-hook, whatever. Oops. Okay. Let's exit. Exit here. And we are here. We are now exiting some context. We are exiting the train. Sounds good. Let's grab the second one. Where is the second one? Poor boy is still here. Debugging. It's still deep in the train step. There was some, there was some metrics that aggregate. With metrics aggregate. Okay, we never stepped through this, but it just logs the loss if TPU, otherwise just some modifications. Okay, that's not really important. Reduce log and stats, where is this called? Here. Okay. Exit, and that's it. Nice. Okay. Let's just go here, and we can remove everything except for the validate and save. Let's hit F5. Until we go to here. Let's see what's being done here. Get the training time. Trainer. Cumulative training time. Should we save? Depends on whether end of epoch and save interval. Okay. Or should stop, or This just decides when we save the checkpoint, I assume. Do we validate? Validate interval updates. Didn't I set that to 200? Yes, I did. So if epoch, oh no, that's actually for wait, this is just important to understand. When do we hit the do validate? When do we set it to true? We can always force it to true by just setting it, putting it to what variables, and then modifying the value manually. But to save, just this is going to be false for now. Should stop, should save, just saves the checkpoint. Does this do any meter stuff? Does this measure anything? Not really. Not really, except for the time. We don't care about this. Maybe something happens here and here, and then reset dummy batch. Okay, let's just wait until we hit either this or this. Hit F5. Remove this as well. Okay, now it's running. Update 200. We should hit after this one. The validate interval is obviously specified in epochs, not in number of updates. So maybe that was my misinterpretation. They should have set the epoch or number of updates so that it's clear. Okay, now it's logging, which I said we don't need this anymore. We understand it. We understand all of this. When is the end of an epoch? How is an epoch defined? While we're waiting here, let's just see what's going on in the Discord. Oh my, it's already past midnight. Interesting. Okay, finally, at number of updates 500. Why now? Why now? Did I set anything to 500 up there? Why is that a surprise to me? Did I set 500 anywhere here? I did. Warm up updates there. Validate interval updates. Okay, makes sense. That looks like is the cause of this stop. Validate interval updates. Here it is. Or if this is bigger than 0 and number update is bigger than 0 and number update is divisible by this. Okay, so every 500 will be stopping to validate. And what do we do there? This is the fun part. Enter. Begin for subsets. for different subsets. Just log stuff. Is this decorated? No, it's not. Get the iterator. Oh, we set a breakpoint here because I guess ignore. Because this one. Is this running on a Spark cluster? No, this is running on my on my local machine actually. Parallel data parallel world size is 2. Ah, interesting. Oh, that's what I was looking for. Okay, where is this set? Where is this set? Rank. Nice, we found accidentally the potential solution to my confusion. Where is this set for the name of Lord? Trainer. This is where it's used. This is where it is used again. This is where it is used. Used. Wait, then maybe just where does one call that? Aha, because it calls, okay, it calls the data parallel world size, which goes here. Okay. How come you left Microsoft? Wow, that's been a long time, man. I don't know, I think people are idolizing big tech companies a bit more than they should. You can do better work at startups. There are pros and cons, but for me, I saw how it looks like and gained experience and worked there, but not my cup of tea for like long term. Too bureaucratic, too hierarchical, too little agency. Number of workers. Okay, let's go back to the, before I start ranting. One exit here. Okay, progress. Well, it depends on your preferences, right? It might be better for you, but you have to know yourself. I already have enough money, I don't have to think about it in the near future, but I can focus on building cool stuff. And that's what I'm trying to do here. Create a new root metric aggregators, so validation metrics don't pollute other aggregators. For example, the train ones. Okay, fair enough. Create a new root. Interesting. Let's see what this does. Enter. Whoops. Whoopsie. Create a new one. And if a new root, then grab the copy, then clear those ones, and then copy there and clear them. And now they're empty, and we just add this, and we yield. Oh, I hate when it exits without showing me what happens. Okay, always put a breakpoint after these context managers, that's the learning. Hit F5. Where do you currently work? Sweep, I'm not sure how to pronounce your surname, sorry. Sample. Okay. Uh-huh. Oh, nice. Sorry, I can't, because of the name and the image, I can't connect with the person from LinkedIn as well. Okay, let's enter the validation step. Let's enter here. TPU, what happens here? So we create a new aggregator, valid, and we store some stuff. But what's that stuff? We convert this into eval mode. It's a Fortune 100. How come Fortune 100 companies make you peanuts? Are they that cheap? Okay. Let's exit here. Let's go. Yeah. Where do you live currently? It also depends where you live and position, I mean. Okay, loss. Validation step. Let's see whether something interesting happens in the validation step of the task. USA. Nice. Yeah, USA is a tough country because there is an extreme power law. If you're rich, you're really rich. If you're otherwise, you're struggling. Medical system and everything else. Okay, so we enter the forward. Okay, so we can just exit from here. Exit, 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 exit. Okay, here we are. Retrieve the values. And then we get the logging output. The usual stuff. 2 types of losses, number of token sentences, and sample size. Okay. Task. Grab the languages. Okay, it's the same. Okay, we'll have to either add something or this just tracks the losses. I also want to understand what's the sample text. What's the... Maybe for the first run, I don't know, maybe for the first run we don't really care, right? For the first run, just track the losses. If the losses are going down and they're not overfit, we don't see any overfitting, in that case, we can just keep on saving the checkpoints, and then at the very end, grab the checkpoint and just do some sampling of the text. And yeah. Okay, this was a learning nonetheless. I'm gonna kick off a run during the night. Just curious what will happen. Okay, let me go and unblock the second process. What's the best company that pays you to just IC and not be bothered, in your opinion? Ooh, there is a ton of options. That's a hard question, man. There is really a ton of options for... I mean, if you're high up in the ranks in any of the big tech companies, you'll be earning a shit ton of money. If you can go to OpenAI or some of those top AI labs, you'll also be getting a shit ton of money. Especially in the USA. London doesn't have as good salaries as the USA. forward scriptable. Why are we here again? Let's exit, let's exit, let's exit, let's exit again, again, and again, and again, and again, and again, and again, and again. Okay. Okay, just do some aggregation, grab the languages, reduce and log the stats. This is our standard stuff here. Let's just go here, reduce the metrics for the criterion. What time is it in Belgrade? Oh yes, it's past midnight. It's like 30 a.m. 30 minutes after midnight. Thanks for asking, Sarah. That's my girlfriend, by the way. She's wondering why am I still at my computer. Reduce metrics. Let's see what happens here. Number of tokens. Log. Aha. Okay, so this is where we log the number of tokens. What's the no worries, man. What's the thanks. Also, feel free to join the project, by the way. We have a very engaged community already, and you can be like, if you have some native language which is not as common, you can check it out here. We have this so-called language champions document where people have signed up. You put your name next to the language, and then you can help us with verifying data or whatnot, and we'll put you in the credit section on the README of the project if that's something that's interesting. Awesome. Just join again, you'll find my Discord server if you're not already there. On any of my YouTube videos, you'll just find the link, even on this stream. Cheers, man. Log the scalar, log the speed. Number of tokens. Time meter. Why the time meter? Because this is WPS. Okay. Time meter is basically update. Why stream only 144p? How come? Maybe my I'm currently running like a heavy ass GPUs on my system. So if you take a look at my usage of my GPU, it's killing it already, close to the end, close to the maximum. So my OBS might be struggling. Oh, so it's 180p for you. So it's probably on Miller's side. Hey Miller, how are you doing, man? Log speed. I know a couple of people with that name, by the way. I'm not sure which one you are. Looking at the avatar. Are you my capoeira buddy? Eating Persian, it's nice. Going through the logs, number of sentences, and then we'll log. Okay, number of sentences per. Wait, what is this? Batch size, I guess. This is batch size. Yeah, this is batch size. Okay, and then we call the criterion with these outputs. which is loss, and a loss, and tokens, blah, 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 and then call reduce metrics, which basically grabs the loss, sums it up, same here, same here, same here, and then logs as the scalar, the sum divided by sample size, same here, PPL gets the perplexity. Okay, so perplexity is just derived directly from NLL loss. Okay, let's just quickly enter this log derived. I've never seen this one. Derived meter from the function label smoothed. Interesting. Who would have thought that logging is so complicated? Okay, and we're done here apparently. We are done here. Get the smoothed values. 4 keys to delete. We delete a bunch of them and we exit. We exit from the context manager. And we're done with the validation step. Let's hit F5 until we exit this code here. F5 again. And here we are. Get the validation stats. Where are people watching me at 1 AM in Serbia? That's beyond me. Get validation stats. Or even better question, why am I still streaming? This is, I think, almost 4 hours. By the way, my battery might die at one point. If that happens, I'm just gonna stop the stream and I will not resume it because we're already at the very end. Get smoothed values. Get the stats. Because I think this is the last task. I'm just gonna kick off the training run after this. Just gonna kick off a training run. And see what happens until the morning. And then if it diverges, then we can think what to change. And we have a ton of different to-dos for tomorrow. We can go through the IA presentation. I need to understand a bit better what we are logging again. Maybe add some sampling of foreign sentences during the training so that we have a qualitative understanding of what's going on. Okay, so just return back the stats. And stats contains, again, just a ton of this information, batch number of sentences. Okay. Print. And then stats, validation loss append. We are done. We exit. And that's it. Aha, so we do a bit more of validation for what? Only validate the first subset before save. And then we validate on the other ones. Wait, what was the difference exactly? Validation losses. Just a second. Subsets. For each of the subsets, why do we go and do this again? Wait. Get the iterator for this subset. So what are we getting for this one versus just a validation? That's not clear. Let me just add a to-do as well tomorrow. In the validation. What do we get when subset equals valid versus actual languages. Line 539, validate function. Okay, not clear, but I'm just gonna exit and exit from here as well, and exit from here as well. Just go up, remove breakpoint from print, exit here, remove breakpoint as well, exit here, exit, exit, and we're done. Okay, should stop early. Why do we keep on hitting this function? Okay, validate and save. That's it. So we keep on running this on and off, train step, and every now and then we do validate and save. That's it. So there is obviously no option for potentially sampling the text during the training, because I guess that doesn't make that much sense in a general setting where this is FAIRSEC, a fairly general framework. So I guess for machine translation that might make sense in my particular case, but in general they did not implement such a feature. Okay, so I'm gonna stop the training. I'm gonna kick off a run that is going to run during the night. So let's just go back here. Let's see what to-dos are left here because I changed stuff. So let's put this to like 1000. Okay, validate interval every 1000. And then set this back to 12 layers. 12 layers. Is there any other to do here? I doubt it. That's good. Let's quickly make sure this makes sense, and I'm kicking off the run. Feed, this makes sense. Blank pairs makes sense. We're going English, Turkish, English, Hindi. Data arguments, number of tokens, prefixes, that's all good. Temperature 1.3, I've changed that just to kind of balance for the lack of Hindi data. This is good, this is good, this is good. This is okay as well. Log interval every 100. Maybe we can log every, 100 is fine. Validate interval updates. Let's put that to every 1000 as well. Log format is going to be JSON. That's good. Save directory. Let's call it first run. Under model checkpoints, let's find the model checkpoints. FAIRSEC, model checkpoints, save directory, nothing happening there, so we can, yeah, just change it to that name. Keep on interval update. This is just the number of checkpoints that we are keeping. We're keeping just the last one. I think that's it. Distributor world size. If we set this to 1, let's quickly set this to 1 just to test things. Min parameters, that's fine. Application is fine. To do set world size to 2 again. Adam is fine. Update frequency 1, that's good. Max number of updates 100,000 steps. Let's see, that should run until completion, until tomorrow, maybe around noon, a bit more maybe. Weight decay, learning schedule. Very hard to estimate these. What should be the what should be a good value here? Warm-up updates, maybe 5,000 is a more reasonable number, and then learning rate. Label smoothing, architecture, I'm not gonna touch that one. So all looks good, guys. Let me quickly see the run. Open. Okay. Train inner system. We'll be tracking a bunch of metrics. That's cool. Overview. Runs. There's a ton of different runs here that we don't care about. Looking good. Let's kick off train again quickly. Pair6 CLI. Pair6 CLI train. Let's run it and see what happens with my GPU. So currently, as you can see, this is the consumption, the utility, the usage of my GPU VRAM. Let's see, with world size 1, I'm expecting only 1 to basically be consumed. And that's indeed the case. So here it is. Only this one is consumed. Nice. Stop this. So if we could shard, if we could force the sharding instead of data parallelism, we could be running with a much bigger batch size. So that's additional to do. I'm gonna put a to do here. That's for tomorrow. So if we can set model param sharding to 2 degree 2 instead data parallelism, instead of we could bump up the max number of tokens in the batch. Let's go back to lawn.json. lawn.json, where you are, where are you? Here you are. Go back to save. And it's safe to say we can now run our first training ever. 45 minutes after midnight. Training on 2 directions. English to Turkish and English to Hindi. Let's see what happens in the morning. I'm just gonna kick this off and not even think, because there is still a couple of things we do need to do. I don't even know how to spell. We did do this. Okay, so I'm gonna first do this. And then tomorrow, this is related. These are the metrics. Okay. Kicking off the run. Disabling all of the breakpoints. Running, and guys, I'm stopping the stream. This is it. I think this has been very, very long stream, around 4 hours, almost. I think battery's gonna die either way in a couple of minutes, so that's it, guys. Hope you enjoyed this one, you learned something, and catch you tomorrow. Regular streaming schedule, which means starting 10:30 a.m. CET, Central European Time, and then catch you then, guys. Cheers, have a nice evening, have a nice day, have a nice morning wherever you are. Until tomorrow, bye bye.